Welcome, everybody, in this lesson. So I shall first show you some resources on the web, and then we shall examine how netlogo works, and then we start with some example. And in the next days, we can arrange for developing something that could interest just you. I'm waiting some minutes before establishing the scheduling of next lessons, because if somebody else want to join us, so we can discuss all together. So first of all, the website you already have seen, it is this one. netlogo is a platform developed by university. It is open source, multi-platform, in the sense that can be used in Windows, Unix, or Macintosh, and also on the web. It is, if you want to see my other lessons, the site is teaching.complexworld.net, and complex world I don't see this. It has changed the resolution here, so I don't see. Teaching.complexworld.net. Okay. And here you have several courses that I gave, but in particular you have some versions of this course that I gave to my students, to PhD students in Florence for several years, sometimes in Italian, sometimes in English. So in case you can also have easy watch this, but it's not really very important. So let me start illustrating the platform. Yes. En catalan, non. Pour le moment, non. J'ai donné aussi I also gave a course here in Perpignan, say some 10 years ago. Probably it is here. Somewhere, statistical physics from a computational perspective, maybe this one. So this was more focused on statistical physics, and I was here already. No, maybe I can give it in Spanish, maybe in French, but not in Catalan. Well, Catalan is a mixture of French, Italian, Spanish. No. You know that there is a continuity, no, from Catalan, the language spoken in the North Liguria, no. So I've never studied Catalan. And okay, so let's start with the netlogo platform. You can see it is essentially composed by this interface, and if you click with the control, you can detach the code part so that one can work onto Windows. You should be able to control or command click or something on the code part, so that you can have both there. Okay, so the idea of netlogo is that of assuming the paradigm of agent-based computation, has agent-based simulations. So the idea is, just let me see, I haven't shared the screen. No, yes, I shared the screen with. Please let me know those who follow online, because I don't see you. So if you have problems, please talk, with the microphone, on the microphone. Okay, so the idea is to program from the point of view of agents. This is the world where agents live. This is the two-dimensional version. There is also a three-dimensional version of netlogo. So for the moment, we shall examine this, and then we can pass to the other. So this part here, you can control-click, and you can see something, is composed, you see, by a certain number of agents that do not move. Essentially, this is a kind of a field, no? It is a cellular automata, if you know the concept. So you can see, for instance, this is one of the patch. For instance, you can control-click and inspect this patch. For instance, if I change the color to white, you can see where this agent is. So essentially, you can think of a grid of these patches. You can select and click and change the numbering. So where is the origin of the world? You can have it on the corner. You can have it at will. You can also go from -5 to -10 to some. Okay, so you can have the coordinates as you want. And so you see that essentially the advantage and disadvantage of a netlogo is that when you distribute something, you also give people that take it the possibility of changing everything, customizing. So it may be useful, for instance, for playing with kids in some school and so on. Okay. Then you can edit the interface by adding sliders. You can connect it to a given variable. You can establish the range of variation. Buttons. Buttons invoke generally. Actually, you could write just the code here, but normally you can you invoke a procedure defined on the code part, and so when you click setup, you call the procedure setup, and then you can have plots, no, where you can plot something, and some things. For instance, monitor, where you can see the value of some variable on live. For instance, if I type n and then I change this, you clearly you see the variable changed here. Okay. And so now let's start with a very simple example. We want to simulate, for instance, a fire in a forest. So we start defining, for instance, here a density of my trees. So I want to have a slider that fixes the density of my tree, for instance, from 0 to 100%, or from 0 to 1, according to what we want. Then I press setup and I populate my forest with the trees. And then I can have, say, another button that is called go. These are typical. Setup and go are typical. That starts a fire from some random tree, and then it can spread or not. And for instance, one can play, say, okay, for instance, with the children, let's find the critical value of the density for which a fire spreads to a large percentage of the forest, no? And so on. Okay, come. Non, pas de problème. Si tu as besoin de brancher ton ordinateur, d'accord. Non, sinon, il y a cette table ici, tu peux le bouger comme tu veux. Donc, I switched in English. I was illustrating how this works, but we just started. So arrange yourself, and then we shall start again. You have already downloaded the netlogo. You don't have to install anything. So if you have the folder, it should be enough. So let's start. Let's try to launch it, and then we repeat again the introduction. So So the idea, as I was telling, netlogo is a self-contained environment. It has all that you need, so it is also easy to distribute, to give away. It is composed, so you have essentially this interface that you can customize. I shall show you how. And generally, you have also this one, which can normally it starts here. Code, the interface, and then you have also the info where you can write down instruction how to use this and so on. So let's wait to see if you can launch the platform. Oh, someone wants to join us, seems. Okay, so it is now we have to, it is right to start again. So I'm Nadi, and now I can see you, and there could be also another. Oh, it is no, it is Nadi that who wanted to enter again. Maybe we can introduce ourselves. Okay, just right. So if you be the first. Okay. Okay, so I shall introduce myself. My name is Franco Bagnoli. I'm a professor of theoretical physics at the University of Florence. If you are interested in what I do, you can see teaching.complexworld.net is where I put the courses that I give. Otherwise, if you are interested in physics general point of view, you can go to physicx.complexworld.net, where you have a lot of say pedagogic or say popular material about physics, included some. Most of it is Italian, so I think you are not very interested. But there are impossible interviews with the physicists of the past. Okay, we have another student, Lucille. Welcome, Lucille. Can you hear us?
Hi.
So I was illustrating myself. Okay, so, but it is
Okay, thank you.
basically in Italian. While if you are interested in another version of this course, you go to teaching.complexworld.net, and here you have other courses. For instance, there is a history of computers that I gave just a week ago. And there is also other versions of netlogo courses. There is a course on discrete hydrodynamics, epidemic modeling. So there are many things. Okay, so please present yourself. I shall try to, so that you can see. I hope who is here.
I can start. So my name is Raphaël Rousseau. I'm a PhD student here at the university at the GDP, and I do a modeling thesis on the interaction between microRGN viruses and the role of antiviral resistance shaping this interaction. So that's it.
Hello, everybody. I'm Sebastian Pinel from CEFREM. It's a geoscience laboratory. And when I have time to research, I usually do some physical modeling about, let's say, hydrodynamics based on hydrodynamics equation. And right now, I am in the fashion with doing some artificial intelligence, machine learning model.
My name is Amira Morker. I'm an associate professor in computer science in SFASTEF laboratory. So my main research focus on artificial intelligence, machine learning, and modeling complex systems.
And you? Online?
Okay, thank you. My name is Pius Namdemwachuku. I am a postdoctoral student at ERD, but here in Perpignan at Image Aspects Dev. My research areas covers hydrology, climate change, and vegetation analysis. Thank you.
Hello, everyone. I'm a second-year PhD student at ProMS CNRS in ODEO, so not exactly in Perpignan, that's why I'm online. And I'm working on concentrating solar to characterize advanced photovoltaic cells.
Okay, perfect. And so, since we are, I think, all here, we can also plan for the next meetings. Because I would like to develop with you models that you are interested in. So I think that today I can illustrate so the main features and show some examples. Then you are invited to think to some simple application that can be used for, say, teaching or for popularization of your subjects, and we shall try to develop them together. So I think that we can meet the other two times, or I don't know, as you want. I don't want to take too much time to you. I imagine that you are quite engaged, but I'm here for all the week. So let's see when we can plan for the next meeting or for the others. Tomorrow, don't know. It depends on you when you are more free or when you have time. Otherwise, we can also arrange for tomorrow and Wednesday at this time, and then we see if you have more things to do. I'm here at your. I'm available to any time.
Tomorrow for me is afternoon.
You cannot in afternoon. Okay, so. No, you can or you cannot?
I can afternoon.
You can only in the afternoon.
Yeah, only. Yeah.
Okay.
I can come in the afternoon tomorrow, no problem.
Okay.
Yeah, I can come too.
The same thing with me in the afternoon.
Okay.
Tomorrow from 2 to 5, I think it's 3 hours.
We haven't understood very well, Nadi. Can you repeat?
I said from 2 p.m. to 5 p.m. I think it's 3 hours per day. Okay,
so let's arrange for tomorrow at 2 here in this room. I hope it is open. Okay, now we have lost the screen. Okay, so let's come back to netlogo. So netlogo is trying to implement the idea of agent-based modeling. Actually, if you are interested in this kind of approach, there are more powerful platforms. For instance, Repast, so you have to search. Some of them can directly import models developed in netlogo, but they are generally faster. But for starting, this is the idea. So the netlogo is composed by 3 tabs: the interface, the info, where you can just write down the instructions, and the code. And you should be able to detach the code tab by clicking with control. Control click should separate the code from the interface so that we can see both on the screen. Let me know, those, especially those who are assisting at distance, because I don't see you. So if you have something to say, raise your hands or no, and talk. Okay. Yes. No. Okay. So let me start from here. You you have, when you install the netlogo, you have several things. You have this one is netlogo 6.4.0, no? Which is the two-dimensional version. Then you have the three-dimensional version with 3D. And then, as I shall show you, there is also this HubNet client, which is a way of working together on the same project. So if you are developing something which you want, for instance, to have people interacting, fighting, or playing, or doing something all together, you can do this. In principle, you should be able also to drive some kind of robot, but I have never tried this. So there are a lot of different things we can do. For the moment, we are using the 2D. Then there is also this behavior search, which is essentially a way of automatizing simulation. So with behavior search, you can say, okay, run this model for, say, 10 times, by changing this parameter, repeating its simulation, I don't know, some more times, and collect the data from this variable. So essentially, you can, when you have your model, you can launch it on some, say, computer, and it should be able to launch it on several cores if you have a multi-core as usual now. So it can be used to do some relative extended investigation. Okay, so if you are able to arrive just to here, the interface composed. There is always these black things here, which is called the world. Actually, it is composed by a grid. I can say ask patches, set p-color, one of base colors. Let me see if it works. So, okay, I shall illustrate. This is just for showing you how this word is done. It is composed by a certain number of agents or patches which cannot move, but it can react, send messages to other patches, and above this there will be also moving agents. So, for instance, think this as a field. For instance, this could be the grass in some, say, field, no? And then you can have cows that eat grass, and so that move. So you can do all these kind of things. Or this could be the surface of some material, and then you can have, I don't know, some, say, catalyzer. You can have oxygen molecule that attach, and the CO2, molecules that attach, and then if they meet together, they oxidate the monoxide of carbon and producing dioxide of carbon, so like a catalytic surface. Or this could be the surface of a cell, and this can be molecules on the surface, and viruses can attach, move. So you can think of things like this, no? Okay, so the word, let's start with a small word, say the origin in the center, and I don't know, about 21 by 21, because if the maximum and minimum is 10, is 21. No? So you can, this is our word for the moment. Then the first project, so that we can start also learning the problem, is the following. I want to have here, so let me throw away everything. Okay, so don't worry if you have oops. let's start with an empty things. So the first project that I suggest you is something like an epidemics or a fire in a forest. I want to have a slider here by which I can fix the density of trees in some portion of land. So this is my density from 0 to 100. Let's say we use the 100%. So in this case is 50%. I can also write down a percent here. Okay. So this is just for fixing a global variable. So when you put a slide, you are also defining a global variable which is called density. So for instance, if I now add a monitor is something for looking at the live value of some variable. So if I write here density, clearly you see 30, and if I change, you can see the variable changing. Here you can give immediate comments. I shall illustrate you the language, but it is the same like a show density, and you see 9. Essentially here it is just repeating a show some value. Okay, so now this is just for input some values. Then I put a button here. Normally there is always one called setup, and with this button I essentially invoke the code here. Normally I suggest not to write. You should program everything just in this small window, but I suggest you to call just a procedure and then write the procedure here. Otherwise, if you scatter code, you don't find everything. Okay, so for instance, let to define a procedure in netlogo, you use the keyword to set up. I can increase the size to set up, and then it ends with end. So if you check, you see that okay, this is wrong. Setup. Okay, and so it should be black if everything is okay. You can check essentially, no, and so clearly if you go now it runs, it does nothing, but it runs. Okay, clearly here if you can say show density, which is the first command that we have already seen, and clearly every time that you press setup, the value of density is printed here in the command center. Normally you don't use the command center, it's just for debugging, but okay, so now let's start with the programming. So essentially, if you control click on the word, you can inspect the objects that are there. For instance, here I'm inspecting a patch. You don't see anything, but for instance, I can just change the color. So you can see what you are inspecting. It is the unit of space. Yes, it's a cell. One cell, you have here 21 by 21 cells from -10. Each cell has 2 coordinates, no? The X and the Y. In the 3D version, you have the X, the Y, and the Z. Okay? They don't move. So you cannot, for instance, you cannot change the coordinates here. No? If you change this, you are you are not moving this. You are asking another patch. So now it is the patch 2.3, not the patch 2.2. Okay. So the word is composed by non-moving objects, which are called patch because they are patch of field. Moving objects that are called turtles that can move, and the links that can connect the turtles together. For instance, if you want to model, I don't know, molecules or something, you can also represent a link among them, but we shall see. So then, for instance, one of things that patches own is the color. So you can give them some name. You see that now we have changed the patch because I changed the coordinates, so I'm changing the patch. You know, the previous one was this one, the white one. Now I have another which has coordinates. The first one had coordinates 2, 2. So this one. The other has coordinates 2, 3, and it is gray. Here you can have the all colors, the predefined colors. Then you can also define your own colors using RGB and so on. But you have a certain number of colors with names. Okay, so you can have a label if you need. So you can also have some number or something with, say, some color. Okay, just as you say. Okay, so to set up, normally everything starts with unclear all. So the setup normally clears everything. Comments are with the semicolon. You can also abbreviate it CA because it is so often used that clear all or CA is the same. To Lisp. Lisp is the first artificial intelligence language. It is essentially the same age of Fortran, so about the 60s. So the Lisp, now I shall illustrate to you maybe tomorrow, today, I don't know. Lisp is an interesting language which is often used without knowing. So a lot of programs use Lisp in the background. Lisp is essentially a language for manipulating lists. So the idea of the first artificial language study was to say, the idea is that if you define rules of manipulating objects, for instance, say you want to write down Mathematica, for instance, do you know Mathematica? Mathematica is written in Lisp, essentially. So you can define, okay, a formal rule that is A times B plus C is equal to A times B plus A times C. No, this is a formal rule for manipulating a list. No, you have a list of, say, the list should be something like plus. Normally, the first element of a list defines what the list is. Plus A, and then a list of multiplication A, and then a list of plus BC. This is equal to plus multiplication AB, multiplication BC. No, this is a formal rule of manipulating a list. Then you define all these kind of formal rules for taking derivatives, for taking something this, and then you may ask, find me given this starting list, the list with less number of terms, so simplify essentially, no? Simplify an expression or expand this expression. So this is the idea, no? So to explore the tree of all possible manipulation of a list. This is how Lisp was developed, no? Because the idea was that a way of representing intelligence is to apply a set of formal rules to some knowledge corpus. Then it has been used in several different ways. So in this sense, you shall see that we are taking sets and lists. So for instance, the set of all patches. It is a set, not a list, because it has no ordering, while a list is ordered. So a set is a not ordered list. while a list is an ordered collection of items. And in general, all what we shall do here is take some set, filter it in order to have only what you want, and then change something on this set. So we shall see an example just now. So the way of sending a message to a set is ask. So for instance, ask patches. So I'm sending a message to all patches, or I am asking all patches to do something. For instance, set p color green. You see that each patch has this variable called the p color, which is patch color. Then I shall explain why it is called the p color. So set p color green. So this is a very simple instruction. All patches become green. Okay. And now I don't want all. So the sense of the language is this one. You select some set. You can filter, for instance, ask patches with px score less than 0. I mean, this is the left half of the word, no? Because in our word, we have the 0 here. So all of these are all patches with coordinates less than 0. So for instance, if you do this, I now px score. Okay, this is essentially how we proceed. So I take a set. I filter it in some way so that only those that I'm interested in are still in the set, and then I send them some message for doing something. So, for instance, if I want to have a certain number of patches becoming, I don't know, green, for instance, now instead of this, I shall show you in two ways. So, for instance, one is this. I take a random which gives a number from 0 to 99, less than density. So now what I'm saying, I take the set of all patches. Then I ask all of them to extract a random number, and only those who have this true stay in the set. And then I can say have a certain number of patches. Clearly, every time that I click, I change the numbers, no? So this is one possibility. Another possibility is, for instance, this one. Ask all patches. If random 100 less than density, set p color green. So this is more similar to a standard way of programming. Now I'm sending this message to all patches, and all patches runs this. No, it is essentially the same, you know? But the philosophy is slightly different. Here I'm sending a message to all patches. Here I'm first selecting a set of patches and then sending a message. But the effect is the same. Okay, so this is, I think that for the moment is enough for setting up our forest. Then I can add another button, go. This is also typical. And so another procedure to go. And to go, I shall first ask, maybe no, this can be done in the setup. I ask one of these patches to become red. This is the starting of my file. So here, ask clearly one off patches. One off is another operator that takes a set and only returns a random item in this set. It's the same. Okay, we can also with t color equal green. It's the same because once it has become red, if it was green or black before, it doesn't change too much. But okay, we can do this. Set p color red. So now with the setup, no, with is outside. With now the problem is that it is very, very probable that you forget this language every time you use it. Okay. Okay, you understood the idea, no? So patches with p color is green is a set of all patches which have a color equal to green. One off is an operator that takes just a random one. Clearly, there are other operators in which you can say 5 of them or 10 of them. Okay, to go, I would say, okay, all green patches which have a red patch nearby becomes red. So ask patches with p color, for instance, p color equal green. So each patch has a set called the neighbors, which are all the neighbors. You can have neighbors are the 8 neighbors. White neighbors 4 are the 4 neighbors. So depending on what you want. So neighbors with p color equal red is a set of all patches that have in the neighbors of this patch, of one patch, that has a p color equal to red. So now I want to say, is this empty or not? So the operator is any. Let's see that, so pay attention that in netlogo, any character or almost any character can be used as a name of a variable. No? It means that if you want to use an operator like plus and so on, you have to put spaces around it. You can define a variable called I don't know, a plus b without any problem, but it is a variable. If you want to take a plus b, you have to separate the plus with the space. Okay. In general, the convention is that all operators or Boolean operators that returns true or false ends with a question mark. So say if. So I'm talking to a patch, to a green patch. And I am saying here, if the set of your neighbors with color equal to green is not empty, set p color red. If you press the tab, it should automatically format everything. And that's all. So setup, go. So you see that it is a weird language, but it is you can read quite explicitly what it does. No, ask patches with p color equal to green. If any neighbors with the p color equal to red, they become red. So, no. For illustrating, say to some people who don't know how to program, this is not so bad too. Okay, so for instance, now here instead of watching, okay, I can, for instance, here, instead of reporting density, which is useless since I know what is density, I can, for instance, count patches with p color equal to red. Count, it is another operator. You give a set, and count gives you how many items are in the set. So count patches with p color equal to red means counting how many red patches have are here. Okay, it's the same. You can put code either here or here. So let's do so. Actually, this go here, I could have put all this. It's the same. So let me see. If I comment this and copy, I'm commenting this. And I take this one and I put here the code. Okay, it works again. It works the same. So it is not clearly I have to change this, otherwise. So I can also program in this way. It is working exactly the same. I normally just, clearly, if you just have to do something that just counting something, okay, you can put it here. Otherwise, I strongly suggest not to do this. Otherwise, you scatter your code. But in principle, you can define everything here. Or for commenting and uncommenting, it is something like a control semicolon or alt semicolon. So here should be here in the edit on tools. There should be some commenting. I don't know where, but you should have a menu for commenting things. Okay, so one possibility is this one. Now let's say that we want to see the percentage with respect to the initial number of trees. So we have to store the number somewhere. So let's define a global variable, globals, and here you can put the list, something like initial number trees, just to show you that you can use minuses in the names. Okay. So with globals, you are defining global variables. The other way of defining global variables is to assign them to a slider. Okay. So maybe here at the end of setup, I can say set. You don't use the equal sign to assign things to something. Use the word set. So set initial number of trees, count patches with p color equal red. I'm just saving the initial number of trees. Maybe this should be done here before setting fire. No? Okay, so now instead of using this monitor, I may use a plot to see how the evolution of my fire goes in time. So here you see again, you can put code here, no? But okay, let's put the code here just for illustrating another thing. So I want to plot what? Count patches. I don't think I can increase the size of this. Patches with p color equal red divided, notice that you have to put spaces, initial number trees. Okay, clearly you could have written, I copy so that I can increase the size. Okay, so I have written these things. You hope clearly you can plot, you can put this command either here in the Go or in the let me comment this, or in the plot itself. Now if you put this here, this code is executed only when you tick the clock. So here there is a counter ticks, that is the clock. So you have to reset the ticks in the setup to 0 the clock. And then each time you tick, it updates the plots and other things here. So now we can check if this is working. Now plot, there is something not working. Plot count patches with the p color equal red divided in E. I don't see. Initial number. Let me put it in for the moment here just to see what is not working. I want to move this here. Check setup. Go. Division by 0. Initial number trees. Count patches with p color equal to not to red, to green. This is why I got the. So clearly the number of trees is the number green, not red. Okay, now it should work. So you see this. Clearly I have to adjust, say, y max to 1, just to, or to 0.5. It is auto scale, but you have to start with some value so that you can see the curve growing. And now I can copy this if I want to here just to see that it is still working. Now, okay. This is more or less ready. So you can put either here comments or in the plot, in the monitor and so on. Now the last things for this is that you have seen that you have to click a lot of times. Then you can trigger the forever button, the forever flag, and now you just have to click once and it is clicked automatically by the program. You select and you have the forever button here. Clearly you can stop from the procedure saying stop, but normally it is like you prepare the system and then you launch the simulation. Now we can say try to with say instead of 10 we can say 100. So having a small a larger number of cells. So now something more interesting, no? Or you can also run it slower Okay, set up. You can trigger the speed of the simulation. So faster means simply that it doesn't update the screen. Slow, it means that it updates the screen during time. There are also tricks. You can suspend the visualization from in certain points of your code so that you don't you speed up because you don't update the visualization while it is not needed. But this is an advanced term. Also, again, this is essentially how it works. This is a kind of cellular automata, no? Where there is a local rule that is implemented by all cells. Is it clear? Okay, now, for instance, let's try to do the same, but with a variation. I want to, because, for instance, one of the goals of this is to find the critical density for which there is a spreading of a fire, no? Clearly, the idea is you can repeat this several times and see, accumulate results and so on. But it is quite boring, especially if you want to do this in a class with students. So the idea is the following. Let's put, instead of putting the same density on all your lattice, you are putting a gradient of density. So say that from one side you have full of trees, and in the other side it is empty, or no. And then you start the fire from one side, and you see how up to what part it will advance, and that should be give essentially the critical value of these things. No? So okay, let's save this. As a first example in the shared folder that I already communicated to you, I think. If I'm able to find this, should be this one, netlogo Perpignan, and this say forest fire. Okay, so you can also download it from the shared folder. And okay, so now maybe we can start from scratch again. So new. I have saved this. Okay. Just since we have this, you can also export a project as an HTML file, and this can be run inside a browser. Essentially, it compiles the code in JavaScript. So we can open file. The problem is to find this one. No, not this one. Netlogo. Open file. It is netlogo Perpignan. Oh, this one. Okay, forest fire. So you see that you can run this also from the browser. It is extremely slower, so, but still you can modify everything. Here you can change in authoring mode, and then you can have the code here, edit and change so add things and so on. So it is still quite immature, but you can distribute. This is quite useful. For instance, if sometimes, for instance, here I have a course. It is in Italian, but it is not really very important. Here there is some course about how to model epidemics using these things, and then you can click and have people watching. You can put a QR code, for instance, and so people in the room can just test if what I'm saying is true or not. And this is quite nice. I've seen that especially young people are extremely so like this. You can use your phone. You can try if you want. Take this, and you should be redirected to this forest fire game. Clearly, you have to design things for the screen of the phone, which is not exactly the most so handy way of running simulations, but you may play with this. Which is an interesting things, because imagine trying to develop something using JavaScript or using tools is not so easy. So this is an interesting way of using this platform. Okay, so let's and you can embed, you see in the presentation, so you can capture the attention of your audience with games like this. Okay, so let's start with the second example, and then we can make a small pause if you want. So let's try together. The idea is you can suggest what we should do in this new example. So the idea is the following. Let's suppose that we have a more rectangular, world like this. I want to set up the maximum and minimum of density. Okay, the idea is the following. With I set, say, left part is 100%. Do you want to? How I change this? No. You select the world, and you select the values of your field. So for instance, now it is the double and the x direction with respect to the y direction, just to have it more rectangular. We can have a 150. Clearly, when you change this number, you have also to reduce the size of the patch, otherwise it grows. Normally, you can put it to 1, and then you can change it with your mouse. This is the easiest way. You put 1, and then you extend the field as you want. So the idea is the following. Suppose that the left part is minimum density, we can start with 0. The right part is the maximum density. We can put it 1. Say, let's use a continuous number. Each patch has its own density, its own probability of having a tree. Okay, this is the probability of having a tree. And when I press setup, I shall set this value. So let's start designing the interface. I have a setup here. I need to have a Go just to run, which is forever, but for the moment, don't put forever, just for debugging. Setup and go. Then I may need to have 2 sliders, max, min density, say from 0 to 1, step 0.01. just to change with respect to the other, no? Okay, it is from 0 to 1, step 0.01, and this variable is called the mean density. Then I put another one, which is called the max density. Not very original, from 0 to 1, step 0.01, say. And then we can have a plot here. Say, for the moment, I don't put anything here. And okay, like this. So that, and then here I can have the profile of how many trees have been burned up to this point. This is more or less the idea of what I want to say, okay? Okay, so now, clearly, here I need to have two set up, and two go, and so this is the infrastructure. Now I need that each patch has its own value of this probability or density. So I have to declare patch's own density. Now with this I'm saying that now each patch has, and I can check here inspecting a patch. Now, not only it has a X core, Y core, color, label as before, no? But now it has also the variable density. So it is rather interactive. Every time you change something, it is reflected immediately on the interface. You don't have to compile or to do some special things. So now in setup, clearly, I start with the clear all, as usual. Then I ask patches. Now we have now to do some mathematics. I have to define the density, scaling the range from minimum density to maximum density with respect to their coordinates. I think that it is better if now I put not the origin here, but on the edge, the left edge. Okay, so now I have the first left row is 0. 1, 2, 3, 4. It is much easier to make a computation in this way than it is clear it is just shifting. But okay. Okay. So I have to, each patch has, so set density. So I have to take the coordinate px core. I divide it by the maximum, which is called the world width. World width is the horizontal size of the world. So now this is, remember you have to space it with this, to separate it with space. This is something from 0 to 1. Then let me put some reasonable values of this, say something like this. I multiply this, I can put some parentheses, not necessary, but just to see. This times max density, then let me go there. Max density minus mean density plus mean density. Okay, no? This should be the linear interpolation between max density and minus density with respect to the coordinate. No, without this. Set density this. Okay, let's check. If I press setup and then I inspect something here, density 0.15. Okay, just here should be 0. Almost 0.10, which is this one. While on the other hand, it is 0.1. Why 0.1? This is not px score. Divide the world with times max density, which is 0.8. So the difference between, so if I put 0 and 1, set up here. Okay, no, something wrong before, because now it is 98, it is okay. 0.98 should be this one. Okay, so now when I have set this, actually it could be just a local variable, but now if random, now I have to use a random float instead of random. Random float gives clearly a floating number, while random gives an integer number. So random float 1 less than density, set p color green. Clearly, I could also not have defined density. It is just a local variable just to compute this quantity here instead of putting it here. If you don't want to use a global variable, you have to define it using let. Let defines local variables. Then you use a set to change their value. You can also stay here. Let's see. Okay. So now I'm setting up a gradient of density. Clearly, if I change this, should say end with say half density here. Okay. And now I can just set a fire to all these trees here. Say ask trees with trees patches with. How can you select this one, the ones that are there?
Which one?
And just let me comment this. This one. Yes, you see that this is called max px score. The maximum of coordinate is called the max px score. So with px score equal to max px score. So patches is the set of all patches, but I want only those that have x coordinates equal to the maximum of the x coordinate, which are the ones in the edge, no? Set p color red. And so if now I should have a line of red patches here. Then I can also reset the ticks if I want to. Not very important here in this model, but now reset tick is just to reset the clock of the system. And then here normally you tick when you go, but it's just to say how much time has passed. And to go, this is again the same. Ask patches with p color equal green. If you want, you can also add here and any neighbors with p color equal red. You can, so again, you can either use this to select, or you ask to all patches if you are green and you have neighbors with p color equal red, then so this is the same. So you can write it like this. Probably it is not so readable to write all these big selections. So, but you can do set p color red. Clearly, otherwise you can say ask patches if p color equal to red and any neighbors. So let's check setup. Go. Clearly now I can have it forever. Go. Brr. Okay. You see that you can still keep go clicked and then run setup. You see that it ends more or less the same position. Then clearly, then we increase the number. This is just for checking. Okay. Now, in order to automatize everything, we have to stop the go when no other, when everything is no more new burned trees are there. So let's say that we define a global variables new burned trees. No, this is just a variable for the moment. The idea is that I set this set new burned trees to 0. If any of this is burning, I increase this variable. Quindi set and then here, if new burned trees equal to 0, stop. Okay, so now here I set this to 0 for all. Then each patches, if it is burning, increases the number of burned trees. If it is still 0 here, it means that no new tree is burning, and so I can stop. Let's say, okay. So you see that now it is deselected automatically the go. Okay. And so, for instance, at this point here, I can stop. But first of this, I can plot. I can draw the plot. No. And so let me see. Now I have to scan, say, all the X, no, and count how many trees are there. So let's do it in a rather, not in the spirit of netlogo, but in some cases you want to have to use the standard ways. So let X 0. This is a variable just for counting, no? Unfortunately, it has no for, so you have to use a while. While X less or equal to max px core, let X min px core. While it is less than the maximum, less or equal, plot x, y, x, and count patches with p color, with, let's say, px core equal x, and the p color equal red. No, I'm counting the patches with these coordinates and red. Maybe we should divide it by world height, so that when I increase the size, I can scale everything. And the plot xy, as you can imagine, is plotting not just, if you use just plot, it increases by 1 the plot. Here it works the same, just for introducing a new command. But and then I have set x plus 1, because if you forget this, it will never stop. Okay, I think that this is enough. Now you see that even though it is quite a weird language, it is extremely readable once that you have written. The problem is how to write a working code. Okay, so let's see if it works. Okay, here I have to change the maximum, say 0.4, 0.2, then let's see. Okay. And now okay, it is clear this. Now, just for having something more clear, instead of having the coordinates, I would like to have the density. No, because so I have to scale the plot from minus, instead of going from 0 to something and from 0 to something, I have to scale this at least from minimum density to maximum density. No, so this is done, for instance, here. Set plot x range, if I remember well, yes, it is blue. Mean density, max density. So this should set, okay, let's check here. Okay, now it is run, the interval is essentially this one. And then here, instead of plotting x, I have to essentially plot this formula here. So let me define let d0 and let d0 here, set the x divided by world width times this should be the density corresponding to x, and so I can plot this. No, this is the counter is still the coordinates of patches, but instead of plotting x, I'm plotting the scaled value of the density corresponding to that x. So let me see if it is working. Now, maybe I have to. Okay, so now when I use the mouse to go there, I can see, okay, this is density 0.37 instead of x coordinate something, you know? So for instance, now let me increase this, instead of 200, say 500 or 800, and here 200. Let me, okay. Okay. Oh. Not wanting it to become smaller than one. More or less it is what I need. I can change the others if they, okay. Just to have the plot more or less with the same. And so now, okay, so you see that now they correspond essentially to the same values. Maybe we can move let me see, maybe this off. Maybe this is nice, just to, and now you can say, okay, let's try to refine the interval. Okay, you see that now we have a periodic boundary conditions, not normally, but I don't want this, so I can say wrap doesn't wrap doesn't wrap horizontally. Probably this is too big, pointed. Okay, I have to reduce this a bit. Okay, so you see that now you have another ways of presenting things. Okay, let's save this as say forest fire gradient or forest fire gradient. Okay, and we say we can make a small pose, and then we add agents on this that I don't know, maybe drones that are trying to stop the fire or something like this. Clear. Here it is. No, clearly, I'm going fast. Stop me when you don't understand, because clearly. Now, I shall show you where one can find all these the code. Yeah, you can find everything, but I have to show you where you can find the description of all these operators, of all these things, because clearly. But this is just for beginning. So let's stop for say 10 minutes. You can have a rest. So questions, comments? Let's come back to our online participant. Have you followed the illustration? Sorry for not interacting with you so often, but I have a limited screen. Maybe I could also use this screen. No, but I would need another connection, which is not.
C'est lequel, 15 de mai 10h08.
Oh, I can put the link, I can put the link here on the screen if you want to download the code.
Okay.
Hmm?
Yeah.
Do you have the link to download the examples? Yes.
Yes, I have the Google Drive, right?
Uh-huh.
Yes, I've downloaded them.
Okay. Are you able to find this? Okay. So. No. I would like you to be able to download the things from the shared directory. For instance, you should have there this game also, no? Where you can have a Monza. I think this is Imola circuit or Monza circuit. And then you can go and yes. Okay.
And I heard that recently that there was a new discovery with the.
Okay, so we're on break
Yes.
now.
Break. Just up to say 10:50. Say about 8 minutes or 10 or 11 as you want.
Okay.
Up to 11. Say okay. So that we can. Or 10:50, right? 10:50, so that we can start again.
I heard that there was a new discovery about the game of life that in a special. I don't know if you were.
No, not recently. Not. I've worked a lot with the Game of Life. No. Yes. Clearly, you have a lot of. How can I stop? Halt. Here you have. I shall show you in the following a lot of predefined models with the platform, including live. So in several versions. So we can play also with this. But this is not difficult to write down the game. Okay, so let's have a real pause, otherwise we still continue to work. Not really a pause. Maybe I should increase to reduce the resolution here. The problem is that if I reduce too much, let me see. Because otherwise you don't read. But if you reduce too much, I don't have a place for everything. Preset instead of this. This is more or less the same, I think. I don't think it is. Let me custom preset.
I think I found something in this direction. In January 24, there's
I shall see. Just let me see if I can reduce the this slightly better. Okay, let's try with this one. So you have It's larger fonts. Okay, let me.
Well, I just Googleized it, New Discovery Game of Life 24, and then I found
Mystery solved. The mathematicians found a solution to the problem that just passed.
I don't know if this is it, but
Mystery of what?
yes, this is it.
But okay, I can read it.
Yes, me too.
Oh, we can also play with the game of life. For instance, there is an old paper that says in the 90 something, there was a paper by Perpignan saying that the game of life was at the edge of chaos, no? It is a self-organized critical system. While it is almost, so I can illustrate if you want this, but so for the moment, relax yourself, do some exercise, walk with it.
It's until No, I mean the whole course this morning. We will finish at noon.
At 12.
Yeah.
Est-ce que ça pose un problème que quelqu'un d'autre se rajoute au groupe? On n'est pas très nombreux.
Non, pour ajouter
Est-ce que, en fait, il y a un étudiant en post-doctorat de notre équipe qui pourrait être intéressé, je pense. C'est juste qu'il disait qu'il n'y avait plus de place.
Non, il n'y a pas de problème. Tu vois que je pense que c'est la chose qui peut intéresser beaucoup de gens. Pour avoir une idée de ce qu'il faut être fait avec cette plateforme.
Je pense que je vais en parler à Sébastien. Et, ok, super.
Je prends le train à midi, je vais devoir partir parce que j'ai une réunion avec la mairie et la Carcassonne. Ah oui, vous connaissez Carcassonne?
On essaie de terminer avant.
Ah non, vous embêtez pas, je ne sais même pas à quelle heure part le train, s'il faut, c'est midi 15. Et alors, j'ai dit à Amira que j'avais une étudiante qui est comme monsieur en modélisation de niche écologique d'animaux, de fleurs en l'occurrence. Elle m'a dit qu'elle était occupée. Et je crois qu'elle a eu peur parce qu'il y avait marqué que C'était pas clair si c'était tous les jours ou.
Ah oui, en fait, vu qu'il n'y avait pas encore de planning, je pense que le truc.
Ouais, elle m'a dit j'ai pas le temps et tout.
Ah, elle travaille avec Joris Bertrand, c'est ça?
Oui, c'est ça.
Ah oui, ok, bon, c'est bonjour. Ok.
Et je pense que ça aurait pu l'intéresser parce qu'elle va rentrer en thèse en septembre. Et typiquement, ça aurait été bien pour elle, quoi. Ça lui aurait donné des idées après pendant la thèse d'ici un an ou deux. Je pense qu'il y a des choses à faire parce que là, pour le moment, les modèles de. Donc, elle modélise les habitats des fleurs avec le changement climatique. Ah ouais. Donc, ça lui aurait pu. Moi, je suis un des encadrants. Et je pense qu'il y a des choses à faire en fait. Parce que pour le moment, ils font ça avec du random forest, du machine learning. Et sinon, il y a aussi un algorithme statistique, alors je ne sais pas ce qu'il y a derrière, mais qui est vendu, qui utilise à l'aveugle sans savoir qu'est-ce qu'on fait sur elle. Et grosso modo, je pense qu'il y a moyen de faire des choses avec ça. J'étais en train de réfléchir aussi. Nous, on travaille beaucoup avec les poissons. Et je me disais que peut-être on peut, pas aller dans un aquarium dans la mer.
Non, mais il faut que vous pensiez à des exemples qu'on peut développer. Ouais. Si on n'a pas le temps de les faire ici, on peut continuer après.
Oui, de toute façon, là, c'est vrai qu'en 4 jours, ça va être dur, mais effectivement, il faut que je réfléchisse un peu. Parce que toi, tu modélises quoi?
Moi, c'est plus de la modélisation des systèmes dynamiques, donc c'est de la modélisation écologique. Je fais des modèles épidémiologiques, des modèles en temps continu, des modèles en temps discret.
Mais sur des plantes ou sur des...
Alors, en fait, moi, je travaille sur du coup, les micro-algues et les virus, en partie, et je travaille aussi plus sur des macro-organismes, donc l'interaction, c'est châtaignier, cynips. Je ne sais pas si tu as déjà entendu parler de Jean-Loup. Donc, c'est encore un autre type de modélisation, du coup. Mais en fait, ce qui est intéressant là, c'est que il y a une application de ces modèles-là pour faire de la microévolution. Et en fait, ça serait super intéressant. En fait, ça ne prédit pas ce qui se passe réellement au sein de ta population, ça se base à une échelle d'abondance écologique population. Et du coup, utiliser des modèles où chaque individu peut être représenté, ça pourrait être vachement intéressant pour voir un peu mieux comment ça se passe au niveau, s'il y a de la diversification ou pas. Voilà.
Ok, je pense qu'on peut recommencer en temps à Minambe, disons. À Voici. Et on recommence 5 minutes parce que Amina est disparue. We shall start in 2 minutes.
5 minutes, okay, no problem.
Let's open again, say, forest fire. Okay, we can start. So the idea, just to introduce the moving agents, turtles, we can say, let's try to slow down the evolution of this so that we have time to change something. So, for instance, we can introduce a probability of taking fire, so setting fire, say with another slider. This is not really interesting. We can remove. Say, let's put here some p. I don't want to spend too much. So essentially, this is a new variable. Okay, I mean, here we are. Let me. I have introduced a new variable called the p, so that instead of just setting fire, I set fire with a certain probability. If random float 1 less than p, this is I use this just for slowing down the evolution, so that even though we are say above the threshold, the evolution can be slowed down. Maybe this could be even 0.1, 0.001, so that okay, no, so it starts, but it goes slow enough. And now the idea is that we can, for instance, set up a drone or an helicopter that throw water trying to stop this fire. Well, we can maybe we can drive it using the keyboard. We can just drive, but for the moment, just put the drone. So first of all, but let's have a look on what is here. First of all, you have to essentially use this netlogo dictionary. This is a web page where everything, every operator, every quantity is listed. So you see that there are things related to patch, like I don't know, X-core or a random PX core and so on. Then there are things related to the moving agent, which are called the turtle. Then links are a connection among turtles. For instance, you can have two turtles with a link among them, and then you can do something with this. These are things related to agent set. We have already seen, for instance, any count. Where is count? There should be somewhere. These are operators. So, for instance, any, if you click here, or is, there are several. Any agent returns true if the agent is not empty and false otherwise. Then there are things related to color, to if, then, control flow, procedures that I shall illustrate in another lesson, anonymous procedures, and then lists, for instance. So you can manipulate a list, say, putting something at the end of the list, at the beginning of the list, length of the list, finding something inside the list. You can imagine all this. Then plotting, and so on. Okay, so here, in general, it is something that you have to consult in order to find what you want to do. Okay, then turtles can have a given shape, and you can also edit the shape of the turtle. So, for instance, we can use, say, we can try to have some helicopter here. I can start from this, say. Oh. Oh, not so easy with this mouse. I would like to have a cross here. I need a real mouse, otherwise it is almost impossible to catch this small. Yes, I also have, but okay, let me try with this. I can also take this one.
I know this.
But I think this is enough. Okay. No, I don't need it. And then maybe we can put a circle here. Okay, this could be an approximation of the drone, no? Okay, so let me call it drone. And then in the code at setup, you can also create a drone. So this is the keyword is create turtles. Can be abbreviated as CRT, since it is used so many times that it has an abbreviation. But okay. Then you say how many, say 1. Yes, you are creating a turtle, an object. Then a turtle, so a turtle has coordinates. Now they can be any floating number, not just an integer number like pages. And it can have a shape. So set shape drone, set color black. Okay. Color black. Set size, say 2 in unit of patches. And so when you, maybe 2 is 220. Okay, so this is our patch, no? So our turtle. So you can inspect turtles, you see. And turtles have, so they have own color, can have a label. You can now you can move it. So if you change the coordinates, this moves. Turtle has also a heading, so a direction. For this is not very really important, but for instance, I can rotate it. I don't know if let me see if it is rotatable or not. Maybe not. Let me see. Turtle shapes editor, my drone. It was probably not rotatable, but I can make it rotatable. Maybe this is smaller. Okay. So now it can rotate. Just for clearly, in some cases, you need to have a heading. Or remember, this introduces a thing which is not so easy. The angular coordinates in this world is that 0 is north, and they are clockwise, so quite different from the usual setup. It is more natural to have north there instead of having north at right, no? Because right here it is more. But it is so. For instance, we can say to go just to do something. Ask turtles. Set heading +1. So heading. So just to have this rotating, okay. Just for fun. Okay. Now we can drive it. I shall show you how. And suppose that now this throws some water that makes the tree blue, and they cannot be burned. No. Okay, so first of all, let's put something for moving this, so we can have maybe here. We put a certain number of buttons. Actually, we could use a Unicode character, so we can have arrows if you want, just to look for the. But for the moment, up, down, it's enough. Up, down. Oops. I think that the left cannot be used, so I use go left. Left is a keyword. But then I shall go right. Okay, so maybe the other can be go up and go down, so that they are more uniform. Then we shall use this to put the Unicode, or I can do just now. So let me Unicode arrows. So for instance, I can use this. And then this. Now this is go right. If I put this is go left. This one. Okay, and then I can also put some letter here. So for instance, J. Here I. Unfortunately, I can only use letters. Say J, I, N, M, and say L here. And okay, and then maybe another button for throwing water. Maybe W. Okay. So, and now I have to say actually, we could also have just a single procedure with some argument. Maybe it is more interesting. So let me, instead of go, since go it used here, we can, okay, I change the wording. So go up, or go, say, let us assign a number, which is, well, okay, it is the same as up. So instead of this, can be called the run. So I can use go. So I use just a single procedure. Instead of defining 4 procedures, I use one. Go right, go down, and go left. I may save this so you can download if you want. Save as forest fire drone. So if you want to download. Allora, quindi this is to run now, the old go, and to go direction. This is a way of passing an argument, declaring that I'm passing an argument. And then I can use un if else in order to have several, but I have to put, if you have more than 2 arguments, I have to put a parenthesis in order to delimitate. Actually, Lisp, somebody says that Lisp is a lot of irritating, useless parentheses. Normally, it has a lot of parentheses. This is a Lisp with a lot of sugar in order to avoid all these parentheses, but sometimes they are still there. So if else direction equal right, no? Then I do something. Maybe I can put a direction equal up. I do something. Direction equal left. I do something. And then else clearly it is down. So this is just for setting up the structure of what I need to. This can be down. Okay, so what I should do? I should ask one of drones. I have just one, but maybe I can command so a squad of drones. So ask one of drones, turtles. Actually, I could define a species of turtles called the drones because I can have different species. But for the moment, ask one turtles. Turtles, yes, turtles. Thanks. So direction equal right, set x core plus 1, for instance, no? Up, set y core plus 1. Set left minus 1, and here minus 1. Okay, let me see if it is working. So set up. Run, no, it is already another execute. Run is another keyword. Okay, so I can now drive my drone. Okay. Okay, and now I have to throw water. So the idea now, notice that patches have variables called like pcolor and pxcore, while turtles have variables called the color and xcore. The idea is that turtles can directly access the values of the patch below it. So for this, this is why we had 2 different names for the same things, because xcore refers to the patch where the turtle is. And so here, for instance, if okay, to water, I can just set pcolor blue, and this is enough for changing the color of the patch below it. Maybe just if it is, if pcolor equal to green, maybe only maybe or not. It is exactly the same for this mode. So just draw. the fact is that a turtle can send clearly send messages to patch. I shall variate just in a moment, but you can just simply access the variables of the patch where you are. So let's try. So when I go, if I water, maybe here, water is not working. To water. Can you use okay, no, so I have to ask. Yes, I have to address to somebody here. Ask turtles. It should be addressed to somebody. Okay. So I asked turtles to change the color of patches because so set p color blue. Okay, let me see if it is working. So execute. So I water, then I move. Okay, now we can probably throw water to more than just one. So I can say, for instance, ask patches in radius something, I don't know, 5, then we can make a variable. In this case, I'm not changing directly the color. I'm asking patches to change color. But I can use this in radius, and then, so when I water now, clearly I can, so I may, if you want to play, you could say you have a limited amount of water, and so you have to define, so to throw it somewhere. I'm not really stopping anything clearly, but this is more or less the idea. So for instance, here we can define a variable movement. So I can move and maybe I can use this the same. Oh, this could be also a slider instead of say from 1 to 10. Say clearly I have now removed it here. Oh, now I'm should if I'm able. Okay. No, it should stop. Let's try. Because I ask, the problem is that I don't remember the the keys here. Now should stop because only green trees are asked to become. So this is a game, but now you can put some artificial intelligence on the drone and say move towards. We can do, Yes. So for instance, let's so instead of this, we can also have a mode for a drone that is moving randomly. No, let's suppose that we have a button here says random movement, which is forever, and then I can activate, say, with an R. And with two random movement, ask drones. It is go. I make a list just to demonstrate that is not the simplest things to do. Down, I make a list of strings, right and left. I send a message to the drones to take item random 4 of this. Random. So random 4 is a number from 0 to 3. Item takes a list, a number starting from 0, and the list and returns the item of this. Let's see if drones, turtles. Then I change the name of turtles to drones. So random, only the observer can ask the set. Why not? Ask turtles. Because go is not a. It is not a command for turtles. It is already a command. Now I shall explain. Should be like this. Execute random. It is too bad. Now we can play with setup. Maybe this could be much less. And this is more reasonable to see if it is able to. A random strategy could be able to do this. Clearly, we could also say go towards fire. So you see that this is not enough for stopping, and maybe if I increase this, so you can play with this kind of things. So you see that you can do something. Clearly, this is more in the spirit of a game, but you can test ideas on with this platform. Do you have suggestions how to do a modification of this, for instance? Okay, let me see. I can just to introduce the idea of breed. Instead, when you want, you may have more kinds of say things, not just one. Turtles are a generic name for all things that can move, but sometimes you may want to have, I don't know, wolves and sheep, or I don't know, molecules of a given type and molecules of other type. So you can define a breed of different types. You furnish a plural and a singular. And now, instead of create turtles, you can say create drones. In this moment, we just have one species. So ask drones, ask one of drones, no? but it should work the same. And now, for instance, you could have other kinds of say things. For instance, you could have I don't know, sheep that eats grass, which is essentially the same as the drone, but no, okay. So, for instance, let's just have a look at some models, some standard models, just one. So, model library, there is this wolf sheep predation, where you have in this case the grass, the sheep that eat the grass, and the wolf that eat sheep. So it is a kind of Lotka Volterra model. No? And then you can see the amounts of sheep, wolf, and clearly they're moving at random. You can also introduce the idea of chasing, you know, and then you can say change live also the initial number. No, you cannot, but you can say change the amount of food that the wolf gain from a given sheep, or the amount of reproduction, and so you can quickly explore what is going on. For instance, that you can have extinction of wolves, and then if you increase the production of sheep, you have also wide oscillation of sheep that can also get extinct. So, for instance, you can discover that wolves have a stabilizing effect on sheep, because here it depends on the reproduction of each of them. In this case, they got extinct. Now, for instance, now they more or less stabilize. No? But if you eliminate wolves, if you eliminate wolves, the sheep with this reproduction rate probably got extinct after. Yes. So you can play with these kind of things. Okay, just so now, just for exercise for you, try to write the game of life. So first of all, you start with there is a slider, the density, how much cells I have to put. So put a slider on your world. Say density from 0 to 1, step 0.1. Then you need 2 buttons. 0, say, from 0 to 1, step 0.01. Then you need a setup button, and then you need the go button, or execute, or as you want. This is the minimum normally for performing experiment. Then we can say code to set up. So the first instruction of setup is clear all, CA. Then we can ask patches if random floor at 1 less than density, and now we have to decide that we can either work with colors, say patches that color red color, and so on, no? Or we can define some variables, say, but let's work with color. Set p color, I don't know, white. So check if you put the density, say 50%, you should have about 50% of cells which are black and 50 which are white. If you put the density to 20%, you should have something like this. Okay? So now the rule is simply, if you are red, if you are white, and you are surrounded by 2 or 3 cells which are white, you stay alive, you stay white. If you are black and you are surrounded by 3 white cells, you become white. Otherwise, you become black or you stay black. But the problem is that you have to apply this in parallel to all cells. While clearly this algorithm, it seems to be parallel, but actually it is applied to the different cells randomly. You see this because if you put the speed at extremely low value and you press setup, you see that no, they are actually updated in a random order, but sequentially. So we have to say either using colors or using a variable to store the old value somewhere. So for instance, let me define a variable for patches. Patches own number living neighbors. So that to go, we do. First, we ask all patches to compute the number of living neighbors. So it's up to you. How do you do that? Ask patches. What? Set number living neighbors to what? You remember you have a set which is the neighbors. So neighbors, we can check here. Say netlogo dictionary. So if you look for patch neighbors here, neighbors is the adjacent set of the 8 surrounding patches. So no, so set number of living neighbors. I put it here. Neighbors is the set of 8 neighbors. Which, in order to have only those who are white, is with exactly. So with p color equal white. Now we have, this is the set of neighbors which are white. Then I have to count them. And this is the number of living neighbors. Remember that here the cell itself is not included. So we have to change a bit the rules. Okay, but now we ask again. First of all, we ask all patches. Now we check. First of all, if we say go, and then we why it is not stopping as patches? Something not working. Tool alt. Let me save this first, because save as life. So setup is what? It is simply extremely slow. Okay, now go. Now I can inspect, for instance, this one, inspect patch this, not this one, this. It has only one living neighbors. Okay, so you can check when, if you want to, tools, stop watching. Stop. Okay. Okay, you can, for instance, this one, which is this one, has three living neighbors. 1, 2, and 3. Okay, so you can check that it is working. But the cell itself is not. So you have done setup, and then go. Because if you don't press go, you don't execute this code. Let me see. Which, if you press check, it should. Red means that something is not. And because if you call it execute. Okay. So now, if this works, now we can ask all patches to change or not their color. So ask patches. Quindi if else pcolor equal white. Quindi, so if they are white and the number of living neighbors, it is going to be so number of living neighbors. So the rule is that if they are white and the number of living cell, including itself, so we have to decrease by 1, is 2 or 3, it stays white. But we can do the opposite. So if it is white and number of living neighbors is less or equal to 1, I would say, or number of living neighbors is greater or equal to 3. So let me conclude. Set pcolor black. I'm doing the opposite. Since it is already white, I have just to say when he is becoming black. So, but let me check. So it says white if they have 2 or 3. Since it is already white, it is 1 or 2. So it is becoming black if it is less than 1 or greater than 2. Should be something like this. No, the opposite. Else, it is black. So let me split this in two. If it is white, let me say like this. If it is white, then it becomes black if the number of living neighbors is less than 1, so it is 0, or it is greater than 2. Else, so it means that it is black, if number of living neighbors, this time is 3, is equal to 3, set p-color black. Let me use the tab. Okay, should be. Oh, so if else, no, something wrong. This is here. Okay, so this closes here. Okay, if color is equal to white, so it is becoming black if it has either less than 1, because with 1 and this it is 2, so it stays white, and 2. Otherwise, if it is black, it is becoming white only if the number of living neighbors is equal to 3. But I hope. Let's check.
Excuse me, I have a question.
Yes.
So I wrote the exact same thing, but when I checked, it told me that if else expect at least 3 inputs.
Let me see your code. Just wait, I'm looking for the window. Where are you? Here. Okay, I found. So I can stop sharing, and you can share if you want your screen so that I can see your code.
Yes. Should be good now.
Okay. Yes. So ask patches. If else, p-color equal to white, if number of living neighbors. Yes, but you see that go up to 2 lines. No. Stay there.
Oh,
just with your cursor. Then move to the opening parentheses of p-color equal to white. You see that this closes at the end, no? And the next if
yes.
closes should close after set p-color equal to black. Now, if you go to down with the cursor, yes, this one.
This one.
There.
Yeah.
So you should not open another parenthesis here.
Oh, okay.
If no. If number living neighbors less than 1 or number living neighbors greater than 2, open parenthesis.
Yes.
Set p-color black, close parenthesis. Yes, exactly. So you can remove. You can remove the other parenthesis.
This one.
Yes.
Okay.
Okay. Now okay. Now you should. It is okay now. Now you should close the first parenthesis p-color equal to white.
Here?
After this, yes. And open again for the else part.
Okay.
Now you have this, and finally you should remove the last parenthesis.
But
this one, yes. And then space the less, greater and equal of one space, otherwise for a
here.
Yes, you see
Okay.
that it's becoming red, and also the 3 equal to 3 should be spaced. If number living neighbors less than 3, okay, let's check now. Okay, ask patient now. Now you have to close this parenthesis at the end. Yes. Try again. Check. Okay. Aspecting a closing. Yes, you have to close the round parenthesis just before the greater than 2.
Yes.
Yes.
Yeah. Okay.
Okay. Now check.
Okay. It's
And
working.
now, if you want, you can select everything and press Tab in order to have formatted. No.
Yeah.
It's not working.
Nope.
Okay. Maybe
it's fine.
Okay, maybe it is with another key. Probably you should investigate. Okay, I retake the sharing.
Thank you.
And now, okay, we can check if everything is working. We have to select this forever, and it seems to. I hope, but it seems to make this. This is something strange, not working very well. I have to check again. So the rule is a living cell remains living if it is surrounded by 2. Oh, so this is less or no 2, but he is already living. Surround. So probably it is less or equal. And this is a greater or number of living neighbor greater of 3. Let me see. I don't remember. Okay, this is more similar to what should do life. So you have less or equal 1 or greater than 3 or greater or equal to 2. Okay. Okay, this should work. Now, as usual, if you want, you can increase the size of maybe too big. Let me put it 50 by 50. If you want to appreciate the life, why it is called the life, because it seems something which is living.
Hello, Franco.
Yeah.
Please select your density. I want to confirm something with my values.
My density, if you set it too high, should everything dies.
No, yeah, I want to say if you right click on it and say edit, I want to see the values you put.
From 0 to 1, step point
okay,
0,
it's okay. Thank you.
Okay. So maybe tomorrow we shall work on this, say, adding plots. Yeah. Poi no, tu vois qu'il y a tous ces types de configurations. Ici, non, mais il y en a... Attends, je vais faire un petit plus grand. C'est 100 by 100. Maybe. Okay. I may increase a bit the size. I started with a very low density, and you should see some not now. Let's try again. Here is a glider. should appear here. Here another, here another. You mentioned that when it was invented, they used to play this by hand. Okay, maybe tomorrow we can draw something here. For instance, a game that can be done with this is that, okay, maybe with a small dimension, say 30 by 30, you can say arrive here. Now you can change one of this bit, and if you increase the density, you win, and if it is decreases, you lose after stabilization. No, so this could be a game. Okay, have you been able to? Yes, it is typing. Yes, I think it is. Lucille is typing.
What?
Yes.
Oh, sorry, I forgot to turn off my mic.
No, no problem. I want to, since I think it is time to go for lunch. I was wondering if you were able to get the live working or not.
Yes, it worked.
Okay.
Thank you.
Okay, so I save it again in the same folder, and we shall see tomorrow at 2.
Right.
Okay.
Okay. So I can avoid the department reunion. Okay, let me arrange for tomorrow. I think we can use the same link.
Okay.
Okay.
I just move, and then I put another placeholder here, netlogo Perpignan 1, so that I remember the lesson. But it should be the same link. Okay, so I can stop recording, and then see you. Goodbye to tomorrow.
Thank you.